Hey guys, this is a guide on how to use class ripper, a geometry nodes modifier which allows you to create tears, frays, and ripped class. Now there is something similar to this modifier called tear painter by Node Interactives, though at the time I made this, tear painter did not support animations and I needed animations, so I made this. It does now, by the way. Tear painter now does support animations. Now, without any further ado, let's get started on how to work with Class Ripper and how to set up your work. Now, depending on where your mesh is coming from, whether it's Marvelous Designer or Cloud 3D, or maybe you've made it here, there are a few things you need to do. The first thing you want to do is make sure it's a one-sided mesh. It only has one side. Sorry. Let me remove all these modifiers before we get started. It is a one-sided mesh. We don't want thickness, we don't want solidify modifiers, anything. Then, the first thing you want to do is set your UVs. The UVs are the most important part of this modifier. First thing you want to make sure is that they do not have weird orientations. You don't want them tilted or upside down. You want all your UVs, all your main parts specifically, to be the right orientation, to be making sense. For instance, this is the top of the pants and this is the bottom of the pants. I mean shorts in this case. And if you're coming from Marvelous Designer, you want to hit A and then UV and come here to pack islands, disable rotate and set a margin of maybe 0.01 and then hit pack. It's going to pack your UVs without any weird orientations or tilting. And yeah, that's it. You want perfect UVs. Now, what if you've already made your UVs, you have textured your pants and you don't want to lose that? What you can do is come here to the data and UV map, create another set of UVs, and then work on that one. Remember the name of the UV map you will be creating though, because we will be using that. Then what you want to do is create two set of vertex groups. One is called ripped and the other one is called fair. Now you could name them differently and you could set the names by hand in the modifier, but ripped and fair are the defaults. Then let's talk about stacking. How do you stack your modifiers on top of each other? The first thing I want to do is add a subdivision modifier of level 1 because it is already very high detailed, and as you can see it's not doing that much, but I do want to add it anyways. And you can see it's smoothing the corners. What you want to do is go to advanced boundary smooth and keep corners. Also for your UVs, do none, no smoothing on the UVs. And then I want to add my geometry nodes. Now you could do the subdivision afterwards, but I prefer to do it before the class ripper modifier. Now, what if you're working with another blender? In that case, what you want to do is go to File, Append, then find the class ripper. In this case, I'm working on this class ripper, so I'm going to go back, and here you want to find node tree and then class ripper. You want to append class ripper, and then you can use it here. Once you've done that, you can see that we have a UV name, which is UV map, because we didn't change our UVs. Marvelous Designer's default UVs are called UV underline map, but in this case we are using UV map. When we have ripped V group, which is ripped vertex group, which is called ripped by default, fair V group, which is the fair vertex group, and is called fair. These are, by the way, the frayed edges. I know it's called fair, but they are actually the frayed edges, or can be used as the frayed edges. If your mesh is closed, for instance, if it's a watertight mesh like a cube or a monkey, you could use fix closed mesh, and this will fix it. The reason I told you not to use Solidify is exactly because of this and the fact that it's much harder to paint vertex group on a solidified mesh rather than a one-sided mesh. So then after this geometry nodes, you could do your solidify. Let's close these tabs and set a, for example, a thickness of 0.1, and you could do a weighted normal, which gives better normals for the solidified mesh. And this is how you could do it. Now I'm going to disable weighted normal and solidify to make the workflow faster, and I'm going to expand these threads, and we're going to talk about how to paint your vertex groups. Now the first thing you want to do is go to data, make sure ripped is selected, and then go to weight paint, and you can start painting. You could also do Shift Alt Z to disable the weight paint debugging mode or weight paint preview mode, and you can start painting your ripped vertex group. You may notice that sometimes it's doing something like something like this. That's like a small bug. If you change it a little, it's going to take it back. It's a small bug and it's caused by certain values that I have set in the modifiers by default. Changing those values can also help you create them. Now let's create, for instance, a simple tear here. I'm also going to create another one here, maybe here, and make this slightly larger, another one here, and also at the bottoms. And then I'm also going to add one more here. This is way too large, and that looks fine. Another thing I want to mention is that sometimes you may see these glitches. The last time I recorded the video, I didn't get this glitch. This glitch is happening because we are using the fast transfer mode method. If you use exact, it's not going to be glitching like ever. And if it's glitching on fast and you do want to use fast, just add in a little bit more of vertex painting and it's going to fix that. And I think this is fine for this example. Also, let's create something complex. But before that, let's go back to object mode and we have our tears. Now, for the frayed edges, we are going to select fur, go to edit mode, do Shift Alt Z again and select these edge loops. And once you have these edge loops selected, we are going to assign them to fur, and the weight is going to be 1. And as you can see, it's going to create these frayed edges automatically. And if we disable fuzz, you can see that it's also going to extend it to the teared or ripped area. And we have a fuzz fur weight, which you can see is going to make this smoother, make this transition smoother. And let's use exact so that we don't get any glitches. And yeah, that's really it. That's it for how to paint your tears and ripped areas, and how to add the frayed edges. Now, what if we have more complex shapes? By more complex shapes, I mean, for example, let's go back to weight paint and come here to ripped and create more complex shapes. Let's say maybe a circle and a letter. And as you can see, it's all messed up. The way to fix this is checking this fix overhangs, and it's called experimental because as far as I have worked with it, I have never seen any problems. But the solution is a bit not like, it's way too simple. The solution for this fix overhangs is way too simple. That's why I'm calling it experimental. In case you got an error, you can contact me and tell me, hey, this fix overhangs doesn't work. And as you can see, we have all our tears. We went through this. The material for the strings is going to be a string 0.001. Maybe you want to use another material, that's on you. The transfer method, again, fast is going to work sometimes, but if it's not working, just use exact. Especially if you're working with animations, I suggest working with exact. Now, if it's working, if fast is working, it's not going to be ruined at any part of your animation, but exact is like the way to go. It's much more concrete. We have fill caps, which is pretty self-explanatory. It adds the caps to the curves, but I'm not going to use it since it's like just more RAM. We have direction, width, warp, and both, which has both. We have amount, which is the total amount of the lines that we have, of the points that are going to be generating the lines. So if I do 0.001, it's going to be much more. And if I increase the width amount threshold to 2000, it's also going to be much more threads. Now let's do backspace on this so that we get the default values. We have width attachment variation, which is the amount of variation we get on the width lines. For example, the higher this value is, I don't think if you have 20 points, but the higher this value is, the more messed up these threads are going to be. We have width called smaller than. This removes smaller curves of a certain size. Say we have very small lines here, very small threads here, or maybe very small threads in between our lines. This width smaller than is going to remove those areas. Then we have width called closer than, which is going to call or remove threads that are closer than a certain value. Right now it's 0, but 0.02, you can see that it's going to start removing them. This is most visible on warp, but especially if I turn it on, you can see that we don't have any threads here. If I make this make both this 0, it's going to add those removed threads. And if it's not adding enough threads, just make the hole a bit larger. It's going to fix that. But yeah, that's also with the values. We have width called random, which randomly calls or removes these threads to create more variation. You have a spline cuts, the amount of cuts you have on each spline or each thread. So if I increase this, you can see that it's going to have more resolution and more variation on the threads. And then we have a spline resolution, which is the total resolution of the spline. For instance, if I go 3, it's not much visible, but if I go to 1, you can see that it starts breaking. It's the resolution of your threads or curves. 5 is pretty good in this case, especially if your spline cuts are set to 5. But as you can see, 3 is also pretty good. You want to use like the lowest value as possible because it adds to the performance. You have push out, it's an amount of it's being pushed out. Honestly, all these values, all these parameters are very, very self-explanatory, just obviously pushes out the threads, right? And then we have in-out module, which if we are using both is going to add variation, let's say 0.2 and minus 0.2, add the sort of threading and a look to it. Some parts are going to be messed up. Now this in-out module, or the way the both creates this weave pattern, is very, very low quality, like you can see it here. It is going to look not bad from distance, especially if this is fixed. 0.01, let's make it 500, make this 0.05, or maybe 0.1. And as you can see, it's going to fix that. And then if you use both again, and with maybe minus 0.1 and 0.1, it's going to look much better. Then we have trim, min and max, which is going to trim these ripped areas from their middle points. So if I do 0.5, as you can see, it's trimming the areas, the rips or threads. Okay, and then we have noise intensity. Let's go back to Weft. And why are they? Okay. And we have noise intensity, which the higher it is, it's going to add more noise. And if we have, for example, the Spalanca set to 10, it's going to be way crazier. And it's going to sort of add this noise, especially if you have very fur-like threads. It's going to help create that clumping effect between the furs. We have noise scale, which is the scale of that noise, and we have resolution, which is the total resolution of these threads. Right now it's 12. If you do 3, it's going to be a triangle. And yeah, that's as simple as that. That's that. 3 is going to look perfect, especially if you're looking from very far, just in case you don't have a high performance computer. And we have radius, which obviously is the radius, so pretty self-explanatory. Okay, and that's with the threads. With the fur and the fuzz, in fact, some of the values are shared, not shared, but they are essentially the same thing. We have again the transfer method, we have fill caps, we have amount, we have size multiplier, which multiplies the overall size of them to a certain value. And the way the fur and the fuzz are being rendered or generated is that there is a group of small furs. For example, the small ones, the minimum size of the small one is 0.75 and the maximum size of it is 1.25. And how many smalls and how many mediums we have is controlled by this medium size in between. And we have the medium size, min and max, and we have large, which is the large ones. If I do 0.01, you can see only a few of these large ones are going to be generated every now and then, which helps create more variation. And let's do backspace to get the default values. And then we have threaded size, which is the size on the threaded area. So if it's 1, it's not going to be affected. If it's 0.25, it's going to be much smaller on the threaded area or the ripped area. We have angle, which is the angle of them. And as you can see, changes the angle. We have freeze A, which is the amount of, for example, the noise or the freezing they have. We have clump selection. Now, clump selection is going to change when you go to exact the ways being generated, but overall they are actually very, very similar. So clump selection is right now set to 10, clump factor is 0.75. If I change this to 1, you can see that they are going to be more clumped together. And we have clump threshold, which is increasing this allows some of these threads to be missing the clumping. For example, if I make this 0, all of them are going to be clumped. And if it's 0.016, some of them are going to be left out. And clumping probability is how many of them are being clumped, 0.25. And if we increase this, so you can see it's going to clump all of them. By the way, this clump threshold is also their distance, sort of. For instance, if the fur is very long and you have set it to 0.06, set this to 0.016, it's going to leave that very long fur alone, and it's not going to clump it because their distance is way more than 0.016. For example, if it's 1, you can see that it's going to make glitches because it's clumping from here to the end of that end. but 0.016 is actually a very good value that doesn't have any glitches. We have freeze B, which is after we have done this, after we have done all the clumping, it adds another freezing. The freeze probability, how many of the furs do you want to freeze again. We have optimized resolution, which is the final resolution of these furs. Right now it's set to 5, they are going to have 5 edge loops. If it's set to 10, they are going to be much smoother and they're going to have 10 edge loops. We have duplicates, which is obviously the amount of duplicates you want. And we have duplicate radius, which is how far away from each other these duplicates are. And we have resolution, which is again this resolution and radius min and max, or obviously radius min and max. Now with fuzz, the only thing different from this, like everything is exactly the same. The only thing different, sorry, we don't want this when we are not using those. The only thing different with fuzz is going to be a spread. A spread spreads them on 180 degrees on the angle that they are. So if it's high and if we don't have any clumping anywhere, it's going to show much more. This is spreading them in that angle they are being generated on. This is most also visible when you don't have any freeze or anything. 0.5 is again a good value, and we do want our clumps because these are very small furs and they are obviously clumping to each other together. And yeah, we have duplicate radius, resolution min and max, and radius min and max. Sorry, we don't have resolution min and max. And yeah, that's it. It's as simple as that. And that's how you can work with this modifier. If you have any questions, please feel free to ask, and if you have any ideas or you want a feature to be added to this, also feel free to ask that. I'm also going to create another video explaining how this entire node system works. Now we're not going to go through every single node because, as you can see, it's very large, and it's because we have so many different parameters, but I'm going to explain the basic logic of how these tears are being generated and how things work and how you can replicate it in your own systems or create your own version of this. So yeah, I'll be uploading this breakdown as well. Thank you for watching and see you on the next one.